All right, buckle up, everyone, because today we're diving into a topic that's right on the front lines of tackling climate change, capturing carbon emissions. And not just from anywhere, we're talking about those massive cargo ships that crisscross the globe.
Yeah, it's like, how do you even begin to deal with those emissions?
Exactly. But that's where things get really interesting. We're talking about grabbing that CO2 straight from the exhaust and tucking it away,
Like some kind of giant vacuum cleaner for a ship.
basically. And we're getting deep into the nitty-gritty of it all thanks to this report. Concept study to offload onboard captured carbon dioxide. Think of this as your crash course in onboard carbon capture and offloading, or OCCS for those in the know.
Oh, OCCS. I like how that rolls off the tongue.
Right. Catchy, isn't it? But what's really wild is this report doesn't just stop at capturing the CO2. It goes a step way further, actually, and dives into actually getting that captured carbon off the ship.
That's kind of like figuring out how to unload a cargo of, well, air, except this air is actually liquefied CO2, or LCO2 as they call it.
LCO2. Okay, now that sounds a bit more complicated than just grabbing it. Why not just, keep it simple? Why go through all the trouble of liquefying it in the first place?
Well, think of it this way. Ships are all about efficiency, right?
Yeah.
And when it comes to storage, LCO2, though it has its quirks, is amazingly efficient. It's like packing a suitcase. You can fit way more in if you fold and roll your clothes neatly instead of just tossing them in haphazardly. LCO2 is like the perfectly packed suitcase of carbon capture.
Right, so I get the efficiency part, but you said it has its quirks. What kind of diva demands does LCO2 have?
Well, imagine for a second having to keep something constantly balanced, right on the edge of being a gas, a liquid, and a solid, all at the same time.
That sounds tricky.
Right. Well, that's LCO2's happy place. It's called its triple point. But here's the thing. Any slight temperature or pressure change, and boom, you risk clogging everything up with dry ice. And that's a big no-no when you're on the high seas.
Yikes. That sounds like a recipe for disaster. So it's a constant balancing act, like walking a tightrope with LCO2. What happens if, let's say, even a tiny bit of water gets in? That can't be good for the equipment, right?
Oh, it's way worse than that. We're not even talking about a little malfunction here. Even a tiny drop of water, or any impurities like nitrogen for that matter, can corrode the tanks and pipes, and we definitely don't want that.
So what are we talking about here, purity-wise?
We need a purity level of less than 50 parts per million of water.
Wow, that's incredibly pure.
Right. It's like the difference between a casual coffee drinker and a total connoisseur who demands perfectly roasted beans from a specific mountain. No compromises.
Okay, I think I'm starting to grasp why this is such a challenge, and I'm willing to bet that all these intricate details play a huge role in figuring out which offloading methods will actually work, not to mention the cost implications.
You're spot on. This report dives into 4 main offloading concepts. And believe me, each comes with its own set of pros and cons, not to mention a hefty price tag. Keeping LCO2 happy is no small feat.
All right, let's get our hands dirty then. What are we dealing with here? Give me the rundown of these offloading options.
So first up, you've got the classic ship-to-ship transfer, kind of like a mid-ocean rendezvous. Imagine 2 vessels meeting up to essentially hand off this precious cargo of CO2. Sounds simple enough, right?
Yeah, in theory.
But just picture the logistics of coordinating that delicate dance in the middle of the ocean. Things can get a bit, shall we say, choppy.
I can only imagine. And I bet the weather plays a major role, too. You can't exactly reschedule a CO2 transfer because of a little drizzle. So what's the alternative when the seas get rough?
That's where ship-to-shore transfer comes in. Instead of a rendezvous at sea, the LCO2 gets delivered directly to a port, but not just any port. It needs to be specially equipped to handle this kind of operation. And here's the catch. Very few ports around the world are currently set up for this. It's like trying to find a charging station for your electric car back in, say, 2010.
So we're talking about building a whole new network of LCO2 ports, essentially. That sounds like a massive undertaking, and I don't even want to think about the cost.
You're not wrong. This report actually compares the scale of the ships needed for this to those behemoth tankers carrying things like ammonia or LPG serious stuff. It really puts into perspective just how big of an infrastructure challenge we're facing.
Wow, I'm starting to get a feel for the magnitude of this whole endeavor. But there has to be some kind of stepping stone, right? A way to bridge the gap while we wait for these dedicated LCO2 ports to pop up.
That's where things get really interesting. The report throws out this concept of intermediate LCO2 receiving vessels.
Intermediate LCO2 what now?
Basically, picture smaller ships acting as middlemen, collecting LCO2 from those big cargo ships out on the open ocean and then ferrying it back to shore where it can be handled properly.
Ah, I see. So a sort of CO2 shuttle service.
Exactly. It's much more flexible, at least in the short term, while those larger dedicated LCO2 ports are still being developed.
That's a brilliant idea. It definitely seems like a more realistic approach, especially in the near future. But with all this talk of transferring potentially dangerous LCO2 between ships and ports, what about safety? I mean, this whole thing has the potential to go south pretty quickly if something goes wrong.
Safety is, hands down, the top priority here. And this report doesn't shy away from addressing the potential risks. They actually conducted a full-blown hazard identification study, or HAZ for short, to pinpoint everything that could possibly go wrong.
A HAZ study, huh? So they're really trying to get ahead of any potential issues. What kind of things did they uncover?
Well, remember how we talked about LCO2 being a bit finicky with its specific pressure and temperature requirements?
Yeah, it was like the Goldilocks of chemicals.
Right. Well, one major concern is the possibility of a pressure mismatch, especially during those ship-to-ship transfers.
Oh, I see what you mean. If one ship is keeping its LCO2 at a different pressure than the receiving ship, that doesn't sound good. What could actually happen?
Imagine connecting two hoses, but with wildly different water pressures. It wouldn't be pretty. It's the same principle here. If that pressure difference isn't managed with absolute precision, you risk rapid expansion or contraction of the LCO2, which could damage the equipment or even lead to a leak.
Okay, I'm getting it. Pressure is crucial. What else did they flag as a potential issue?
Another one revolves around the purity of the LCO2 being transferred. We talked about how pure it needs to be.
Yeah, like 50 parts per million pure?
Precisely. Now, imagine a scenario where a ship rolls up with a batch of LCO2 that's not quite up to snuff. Maybe a few too many impurities slipped in.
Oh, no.
Oh yes, that could wreak havoc on the receiving ship's systems, maybe even clog things up, and even create really unsafe conditions. It'd be like trying to run a gasoline engine on diesel recipe for disaster.
That's a terrifying thought. So how do they prevent this from happening in the first place?
This report really hammers home the need for clear, concise communication between ships and unwavering adherence to strict standards. We're not talking about sharing recipes here. We're talking about handling a substance that demands the utmost care. Knowing exactly what you're receiving is essential for ensuring a seamless and, above all, safe transfer.
Makes perfect sense. So we've covered pressure and purity. Any other red flags waving in this Hey Says It study?
Well, there's one more we can't ignore: the human element. These are complex operations. We've got specialized equipment, a whole bunch of moving parts, and very specific procedures that need to be followed to the letter. And, well, people make mistakes. Someone could misread a gauge, skip a step, or even fumble a hose connection. We're all human, after all.
Oh, I can totally see that happening. It's like that moment you accidentally put salt instead of sugar in your coffee,
Yeah.
a small slip-up with big consequences, and here the stakes are a lot higher. How do you even begin to minimize that risk?
That's where things like robust training programs, clear and concise communication protocols, and systems with multiple safeguards really come into play. It's all about creating a safety net to catch those oops moments. It's about minimizing those risks as much as humanly possible. And it's not just about preventing those oops moments, but being ready to handle them if they do happen.
Right. So, robust training for anyone handling that LCO2, double-checking those procedures, and backups for the backups. What other problems did they find?
Well, you can't forget the equipment itself. This report goes into meticulous detail about how crucial it is to use, top-notch components, things that can handle the pressure, literally, of dealing with LCO2.
Makes sense. Even a tiny crack in a pipe or a leaky valve, that could be disastrous.
Absolutely.
So they're thinking 10 steps ahead, and they have to with something as potentially dangerous as LCO2. Did they mention external factors that could be a problem?
Absolutely. They talked about accidents during transfer. Like, what if something gets dropped from a crane right onto a pressurized LCO2 pipeline?
Okay, that's just terrifying. Like, out of an action movie, how do you even prepare for that?
Carefully.
I bet.
No, seriously. The report stresses rigorous safety protocols for crane operations. I'm talking securing loads, regular checks on all the lifting gear, and of course, crystal clear communication between the crane operators and the crews on both ships. No room for misunderstandings.
Right, it's like a high-stakes ballet almost. Speaking of things that could go wrong at sea, ship collisions. Especially in busy lanes, that's got to be a major concern.
You're absolutely right, and the report tackles that head-on. Meticulous route planning is essential, as is constant communication with other vessels. They have to stick to maritime traffic regulations, obviously. They even suggest designating specific areas just for LCO2 transfer, like a special zone to keep things organized and minimize those risks.
That makes sense. It sounds like they've really thought of everything to make this as safe as possible. But what if, even with all these precautions, something still goes wrong?
Well, that's where a rock-solid emergency response plan is vital. The report dedicates a whole section to this, laying out all kinds of emergency scenarios step by step, what to do, how to do it.
So it's like a disaster preparedness manual specifically for LCO2.
Precisely. They've got it all covered.
Hmm?
Leaks, equipment malfunctions, even personnel injuries. And yeah, even what to do if, heaven forbid, a collision happens during transfer.
It's good to know they're not taking any chances. But even with a plan, that kind of pressure, it's got to be overwhelming for the crews.
That's why the report really hits home the importance of practice. Regular drills, simulations, the whole 9 yards. The more experienced crews have in a controlled environment, the better equipped they'll be to handle a real emergency.
Practice makes perfect, right? Or in this case, practice makes prepared. You mentioned something called a CIMEPS study earlier.
Ah, yes, SIMEPS, or simultaneous operations. This study tackles the challenge of doing LCO2 offloading while other ship operations are happening at the same time. Imagine trying to transfer LCO2 while, say, the ship's being refueled or taking on cargo.
Talk about multitasking. That sounds incredibly challenging, even without the added pressure of handling a hazardous substance. How do they manage all of that at once?
It all boils down to meticulous planning, timing, coordination, and crystal clear communication. The ship's crew, the port authorities, everyone needs to be on the same page, singing from the same hymn sheet.
So it's like an intricate dance.
Exactly. Every step planned out in advance.
Whoa. The HESAs and CIMUP studies, they really show how essential that proactive, comprehensive approach to safety is. Not just the technology, but the human element, too.
Absolutely. They go hand in hand.
You mentioned earlier they use something called quantitative risk assessment, QRA. Is that right?
Yes, QRA. It sounds very technical, but it's actually pretty straightforward.
Break it down for us.
It's basically putting numbers to those what-if scenarios. Using computer models, they can simulate different types of leaks. It takes into account the leak size, LCO2 pressure, even things like wind conditions, everything. This helps predict how far a CO2 plume could actually spread, how concentrated it might be, and the potential impact on, well, everything. People, the environment, you name it.
So it's like a virtual wind tunnel for CO2 leaks, and then those results help create safety zones, right?
Yeah, I got it. Safe distances, the most effective emergency responses, even influencing the equipment design itself to minimize those risks as much as possible.
It's really amazing how much thought goes into every single aspect. But what did the QRA actually tell them about these offloading methods? Any major red flags?
The good news is the simulations indicated that even in those worst-case scenarios, the risks to people and the environment were still within acceptable limits. Of course, that's assuming everyone's following those meticulous safety protocols to a T.
That is good news. It's reassuring to hear. But simulations are one thing, right? What about real-world data?
That's the thing. This technology is still in its early stages, so there isn't a wealth of real-world data just yet. The report acknowledges that these models have their limitations.
So ongoing research and development, that's going to be key as this technology evolves.
Absolutely. More data, more experience with LCO2 offloading, the better those risk assessments will become.
It's a constant learning curve, especially with something as complex as, well, trying to decarbonize the shipping industry. But at least according to the report, LCO2 offloading can be done safely with the right precautions.
Right, finding that balance between managing the risks and, well, reaping the rewards.
Speaking of rewards, this report dives into the need for specialized training, right? Competency standards for anyone involved with LCO2 offloading. I'm fascinated by that human element. What kind of skills are we talking about? What do you need to know to handle this safely?
It goes way beyond the usual maritime training. This report maps out a whole set of competencies specifically for handling liquid CO2 on ships. It's like a masterclass, all things LCO2.
So they're not just handing someone a wrench and saying, good luck.
No, not at all. It's a multi-layered approach. You need to understand the basic properties of CO2, how it behaves as a solid, liquid, and a gas, and how those states are affected by temperature and pressure changes. And of course, the safety procedures, how to use all that personal protective equipment.
PPE.
Yes, it's about scientific knowledge and very practical skills.
What about the equipment itself? It must require some pretty specific training.
Absolutely. Capture systems, storage tanks, pumps, compressors, and the offloading systems themselves. Each piece has its own nuances. The training is very hands-on.
I bet. You can't just hop in and press a button.
You got it. And to top it off, the report even recommends simulator training. That way, crews can practice handling different scenarios, but in a safe environment.
Smart. It's one thing to read about it, another to actually experience it. We focused a lot on the crews on the ships, but what about the receiving end? Did they need special training too?
100%. This report stresses that everyone in the LCO2 chain, from the ships to the shore-based terminals, needs to be on the same page, singing from the same song sheet. They even suggest joint training exercises to make sure everyone can work together smoothly.
It's like they're building a new league of professionals, all dedicated to making LCO2 offloading a safe and efficient part of the maritime world. It's encouraging to see that emphasis on the human element alongside the technological advances.
For sure, it shows that this technology is about more than just ships and equipment. It's about the people behind it, how they're trained, and their ability to work together.
We've talked a lot about the how of LCO2 offloading, but what about the why? Is it actually economically viable? Or is this just a pipe dream?
That's the million-dollar question, isn't it?
Yeah.
And to be honest, the report, while super detailed on the technical aspects, doesn't quite give us a clear-cut answer on the economic viability just yet.
So it's like we've got the blueprint for a fantastic ship, but we're not sure we can actually afford to build it.
That's a great way to put it. They do provide some cost estimates, but there's a big asterisk next to them.
An asterisk? What do you mean?
Well, they're quick to point out that those numbers could swing wildly depending on several things. Think the size of the ships, where that offloading happens, if the infrastructure's even there, the whole shebang.
Okay, so trying to pin down a budget for this is like trying to budget for a house before you've even picked a neighborhood.
Exactly. Way too many unknowns at this point.
But the report must offer some clues about what could make LCO2 offloading more attractive financially, right?
They do. And one of the most interesting is the idea of carbon pricing schemes.
Carbon pricing, what's that?
Basically, ship owners would have to pay for their CO2 emissions.
Ah, I see. So pollute and pay the price.
Precisely. That economic pressure could be the push the industry needs to really take those emissions seriously. And that's where LCO2 offloading steps, in a way, to reduce those costs by, well, reducing the emissions themselves.
So it's like a financial incentive to go green.
Exactly.
Mm-hmm.
Hit them where it hurts, their wallets. It could be a powerful motivator for the industry.
Makes sense. What else did they mention?
They also touch on the potential for creating a market for that captured CO2.
Wait, so the CO2 itself could be worth something. What are we going to do? Sell it on eBay?
Not quite eBay, but there's a whole field emerging that's focused on finding uses for captured CO2, turning it from a waste product into a valuable resource.
Now that's fascinating. What could it be used for?
One application is something called enhanced oil recovery. It sounds a little counterintuitive.
How so?
Well, it involves using CO2 to extract even more oil from those existing oil wells, kind of like giving them a second life.
Interesting. So not only are you capturing the carbon, but you're potentially getting more oil in the process. Talk about killing two birds with one stone.
Exactly. And the best part is the CO2 often gets trapped underground. So win-win for the environment.
That's amazing. Were there any other uses for this captured carbon?
Oh, you bet. CO2 can be a jack of all trades. It's used in industrial processes. It can even be a building block for things like plastics, fertilizer, you name it, even construction materials.
Wow, that's incredible. So this captured CO2 could actually become a hot commodity. That would change the economics of this whole operation.
It absolutely could. If a strong market for captured CO2 really takes off, it could make LCO2 offloading way more appealing.
It's incredible to think that something we're trying to get rid of could actually be incredibly valuable. It's a fantastic example of how sustainability and innovation can go hand in hand.
100%.
But we got to be realistic, right? This market for captured CO2, it's still in its early stages.
Right. It's promising, no doubt, but not a guaranteed home run.
More research, more development, maybe even some supportive policies to really get the ball rolling.
Absolutely.
Yeah.
But like you said, the potential's huge.
Okay, so we've got the technology, the potential market, but what about the regulations? You mentioned earlier that there's some gray area when it comes to existing regulations and this whole LCO2 offloading thing.
Yeah, and that's a big one. The report really highlights a fundamental problem. Our current maritime regulations. They were written way before anyone even thought about capturing and storing CO2 from ships.
We're trying to fit a square peg in a round hole.
Exactly. And it gets even trickier when you look at something like the London Protocol, which governs waste dumped at sea.
Right, because are we dumping CO2 or are we storing it? It's a bit of a gray area.
Exactly. It's no wonder companies are hesitant to jump in with both feet when the rules are so murky.
So what's the solution here? What does the report recommend?
Clear, straightforward regulations specifically for LCO2 offloading.
Makes sense. That would protect the environment and give those companies the confidence to invest. What else?
It can't just be a one-size-fits-all approach. We need a globally unified strategy. We can't have a hodgepodge of different regulations from one country to the next. That would stifle innovation.
Right, a global solution for a global problem.
Exactly. And the good news is we don't have to reinvent the wheel. There are existing frameworks out there that are already working in other sectors.
Oh, like what?
The report points to the EU's emissions trading system, the ETS, and the CCS directive. These could be great models for developing regulations specifically for the maritime world.
So take what works and tailor it.
Exactly.
It's encouraging to hear there are existing models out there that can be adapted, but it's not just about these big international agreements, is it?
Absolutely not. The report emphasizes the importance of national and regional policies, too. They play a huge role in shaping the LCO2 offloading landscape. Some countries are already ahead of the curve, implementing incentives, funding research.
Leading by example.
Exactly. Those early initiatives, they're going to be super valuable for other countries looking to get on board with LCO2 offloading.
This has been a fascinating look into this whole world of onboard carbon capture and offloading. It's clear this technology could completely change the shipping industry, but there are still hurdles to overcome.
It's definitely not a silver bullet, but it has the potential to be a game changer.
A lot to think about, for sure. Well, that wraps up another deep dive. For our listeners, be sure to join us next time as we continue to explore the challenges facing our planet and the amazing solutions being developed.